Hello students, welcome to the computer science class. I'm Sir Julius Tan, your computer science teacher. Today we are going to discuss basic electronics as part of the robotics lesson. You might ask why we teach robotics in school. Robotics is gaining momentum in many schools worldwide, and while it's important to note that teachers or administer courses in this area should advance knowledge in programming and other skills, students are reaping huge benefit not just for the present, but also for the foreseeable artificial intelligence future. Now, here are 7 areas in which learning about robotics at school can benefit students. First, creative thinking. Not many fields of knowledge incorporate creativity and fun simultaneously. Studies have shown that robotics achieves both. In fact, students love to partake in activities in which they have full control, something that is possible with robotics. And when learners are able to do cool stuff, they want to develop more features. Second, engagement. Hands-on learning activities enhance concentration and attention levels because the more students learn physical skills, the more they want to continue being in the lesson. The third one is preparedness. With advanced technologies such as artificial intelligence, driverless cars, and spacecrafts taking every shape every day, the present generation of students need to be more prepared for technological changes than any before. The fourth one is programming skills. As artificial intelligence becomes more prevalent in homes, schools, and offices, a little programming knowledge will help everyone understand how these robots work. The fifth one here is perseverance. Creating and programming robots is challenging. However, working through frustrations helps students develop a never give up attitude. It imparts determination, which is crucial for any technological or scientific undertaking. 6. Teamwork. Now, robotics incorporates a range of skills and thus promotes learning environment for people with different talents. So, if properly harnessed, it is also promotes a culture of teamwork. 7. Fun. Learning about robotics is fun. And as user experience designers continue to improve how it feels to interact with robots, it will only become more so. And for final thoughts, educators must embrace the latest skills and knowledge for effective teaching. So that's why they should embrace robotics, which is a breaking new ground in learning methodologies around the world. Why robotics is applied in computer science? Robots provides a good environment to work on control. Many applications for computer scientists and engineers involve developing embedded control systems. That includes software that work quite different from a more typical program with inputs and outputs at predictable times. So let's proceed to basic electronics. For lesson 1, it's all about electronic components. So resistor, capacitor, transistor, LED, sensors, and breadboard. For lesson 2, the basic concepts of electronics like Ohm's law, the series and parallel circuits, and the light emitting diode or LED. So the first electronic component that we're going to discuss today is the resistor. So where can we find resistor? Okay, we can find resistor in different electronic circuits. So just like in the picture, this is a printed circuit board. So the component that is encircled there is the resistors. What is a resistor? A resistor is a passive two-terminal electrical component that implements electrical resistance as a circuit element. So from the word resistance and resistor. A resistor is an electrical component that limits or regulates the flow of electrical current in an electronic circuits. Because a resistor has a resistance, so when you say resistance means to resist or to oppose or to limit or regulate the flow of electrical current in a circuit. So if a circuit has a high resistance, then there will be a small amount of current that will flow in the circuit. But if the resistance in a circuit is low, so there will be a large amount of current can flow in the circuit. So the ohm or the omega sign is the electrical unit of the resistance, and it is named after the German physicist George Simon Ohm. So these are the derived units for resistance. So mega ohm, that is 1 million ohms. Kilo means 1,000 ohms or 1 kilo ohm. Milliohms, or we call it thousandths, that is 1 times 10 to the power of -3. And here is the electrical symbol of the resistor. So we have two types: fixed resistor and variable resistor. So in an electronic circuit, or the schematic diagram uses electrical symbols in order to identify what type of component is being connected in a circuit diagram. So as I said, there are two types of resistors. So one is fixed resistor. So under a fixed resistor like carbon composite resistor, film resistor, wire wound resistor, and resistance wire. Then the second one is variable resistor. So like rheostat, potentiometer, thermistor, umistor, and varistor. So for film resistor, for example here, the resistive value of the resistor is controlled by increasing the desired thickness of the deposited film. Then for potentiometer, it's a pot, or an in electronics technology, is a 3-terminal resistor with sliding contact that forms an adjustable voltage divider. So potentiometers are commonly used to control electrical devices such as volume controls, joysticks, and etc. So the comparison between fixed and variable is that when you say fixed resistor, so meaning you cannot change or vary the resistance of the resistor. Unlike if it is a variable, so that means you can manually vary or change the resistance value of the resistor. The carbon composite resistor uses band of colors. So there will be 4 or 5 or 6 band of colors. So in our example, we will use the 4 band colors carbon composite resistor, which is the most common. Now to determine the resistance value, so that is why we are going to use the resistor color coding table. So you have there in the first column color with corresponding value for the first band and second band. The third band here is the multiplier, and the fourth band is tolerance. So for color, in order, black, brown, red, orange, yellow, green, blue, violet, gray, white. So there will be no color, first band color for gold, silver. So commonly, gold and silver can be located in the third band or in the last or the fourth band, which is the multiplier and tolerance for the fourth band. So black is 0, brown 1, red 2, 3 orange, 4 yellow, green 5, blue 6, 7 violet, gray 8, and white 9. So the same number for the first and second bands. So that is why it is important that we are going to familiarize this or memorize the order of color with corresponding value for the first band, second, third, and fourth band. So the third band here is multiplier. So for black, the multiplier is 1 or times 1. For brown is 10, red is 100, orange is times 1000, yellow is times 10,000, green is times 100,000, blue is times 1,000,000. So as you can see in the order, so the multiplier depends on the value for the first or second band. For example, black is 0. So 0 means 1, 0 only. So that is why they put times 1. So when you say yellow, yellow is 4. So that is why in the multiplier, there are 4 zeros added. Then you say white, white is 9. So as you can see in the table, if you count the number of zeros for the multiplier for white that is 1 billion. So that is 9 zeros. So for you to familiarize this, so meaning if you can memorize the table, then there's no need to multiply. So you just add the numbers of zeros. An example here of a 4-band resistor. A carbon resistor uses a band of colors to determine the resistance value of the resistor. So the common type uses 4 band. So just like in the picture. So the first band, the second band, the third band, or the multiplier, and the fourth band, or the tolerance. So you have to take note that gold and silver color always the last band of color. So in this example, the first band here is brown. So brown is equal to 1. Then the second band is black. Black is equal to 0. So you just combine 1 and 0. And then the multiplier here is green. So that will be times 100,000. So Just combine brown and black, which is 1 and 0, that is 10, times 100,000. So the resistance value is 1 million ohms with the tolerance, which is the fourth band, is plus minus 5%. So 1 million ohms or 1 mega ohms with plus and minus 5% tolerance. So you just add the number of zeros. So if you count 1, 2, 3, 4, 5, and 6. So you just write 1, then add 6 zeros. So that is 1 million ohms or 1 mega ohms plus minus 5% tolerance. Remember, the value of the resistance is, or the unit of resistance is ohms. So always use the unit value of the resistance, which is ohms. So how to compute the maximum and minimum tolerance of the resistor? Because the tolerance has a plus and minus percent. So to compute the tolerance of the resistor, so you just convert percentage to decimal by just moving 2 decimal places from the right. So for example, 5%, so that is equal to 0.05 for the tolerance of gold, and 10%, which is 0.1 or 0.10 for the tolerance of the silver. So the tolerance value of 1 million ohms times 0.05, that is 50,000 ohms. That is the tolerance value of a resistor having a color of brown, black, green, and gold, which is the resistance value is 1 million ohms, and the tolerance value, which is 5%, that is equal to 50,000 ohms. Now, in order to compute the maximum tolerance, so you just add the resistance value and the tolerance value. So that is why 1 million plus 50,000 ohms, that is 1,050,000 ohms. And for the minimum tolerance, you just subtract. So that is 1 million ohms minus 50,000. So that is 950 ohms. So here an example of a resistor color code using the 4-band, the 5-band, and the 6-band colors. So in order for you to familiarize or memorize the color coding of the resistor, so we will use mnemonics. So for example, when you say black, black is 0, that is bad. Brown, which is boys. Red, rape. Orange, hour. Yellow, young. Green, girls. Blue, but. Violet, violet. Gray, gives. Then white, which is willingly. So in order for you to memorize it easily, you just memorize this, make this one into a one sentence. So let's say, bad boys rape our young girls, but Violet gives willingly. So that is only an example how to memorize it easily, the resistor color coding. But take note, boys, do not do this. So an example here is brown, green, brown, gold. So what will be the resistance value? So that is 150 ohms. Orange, black, brown, silver. So that is 300 ohms. Violet, green, red, gold. So that is 7.5 kilo ohms or 7,500 ohms. Red, black, orange, silver, so that is 20 kilo ohms or 20,000 ohms. Brown, black, orange, gold, so that is 10K or 10,000 ohms. And brown, black, yellow, silver, that is 100,000 ohms. Orange, black, orange, black, orange, gold, so that is 30 kilo ohms. So that's it for this lesson. So I hope you understand the topic. So there will be an activity for this. So I will send the activity through Google Classroom or to our group chat. So just study this lesson. So thank you very much and good day to all.